Hello guys, this is the complex numbers. There are many problems that cannot be solved by the use of the real numbers alone. For example, we are unable to solve the equation x squared equals -1. There is no real number a such that a squared equals -1. We must extend the set of real numbers r to a new set of numbers to enable us to find the solution of the equation x squared equals -1. This set is called the set of complex numbers. The imaginary number I. The imaginary number I is defined as the number whose square is -1, i.e. I squared equals -1. Let's try to solve x squared equals -1. Since I squared equals -1, therefore x squared equals I bar 2. Therefore x equals positive or negative root I squared. Therefore x equals positive or negative I. The solution set is gonna be I and negative I. Remarks: for sure I doesn't belong to the real number set R. It won't be represented by a point on the number line. The numbers 3i, -2i, root 5i, and so on are imaginary numbers. If a is a real positive number, then root -a equals root ai, because you distribute root on the negative sign, and a, the root of negative sign, will be I, which is root -1, and root I, so the answer is gonna be root ai. The operation on the square root cannot be generalized on the imaginary numbers. If a and b are two negative real numbers, then root a times root b cannot be equal to root a b. The negative power of I. The number I satisfies the rules of the powers. Since I squared equals -1, then I cubed equals I bar 2 times I. For sure I squared is -1 multiplied by I. The answer is gonna be -I. So I bar of 3 equals -I. And I bar of 4 equals I bar of 2 times I bar of 2 equals -1 times -1 equals 1. So I bar 4 is 1, and for sure I bar 5 equals I bar 4 times I bar 4 is 1 multiplied by I. The answer is gonna be I. And I bar 6 by the same way will be I bar 4 times I bar 2. I bar 4 is 1, and I bar of 2 is -1. So 1 times -1 equals -1. To find I bar n, where n is an integer. Cases of the powers of I. If the power is even and divisible by 4, so I bar n equals 1. If the power is even and is not divisible by 4, so I bar n is -1. If the power is odd and the power is just before is divisible by 4, so I bar n equals I. And if the power is odd and the power is just before is not divisible by 4, so I bar n equals -I. Complex numbers a plus pi. Complex numbers are written in the form a plus pi, where a is real part and b is the imaginary part. A plus pi, the first part a is the real part, and the second part b is the imaginary part. The set of complex numbers. The set of complex numbers c is defined as all of the numbers on the shape of a plus bi, where a belongs to R and b belongs to R. For sure I squared equals -1. Here we have the set N, which is a natural number set starting with 0 and go to 1, 2, 3 and so on. The set of integers Z is the numbers starting from 0 and goes to the right 1, 2, 3 and so on, and from the left -1, -2 and so on. And the set of rational numbers, which is Q, is any number is written in the form A over B, where A and B belongs to Z and B is not equal to 0. The set of irrational numbers Q dash is a set of numbers cannot be written in the form A over B, where A and B belongs to Z and B is not equal to 0. The set of real numbers contains Q dash and Q. So N is subset of Z and Z subset of Q and Q subset of R. Q dash subset of R and R is subset of C. The set of complex numbers